Hello, everyone. Am I audible?
You are.
Okay. So, welcome to today's call. And uh, if you haven't already written your name in the meeting minutes, I'll share the link in here. So you can. I'm also entering my name right now. So the first topic was about adding applications into our end-to-end integration test. I have pinged Augustus, although he's not available right now. So I'll push this a little downwards. I'll talk about it. So if anyone else is interested, you can also pick this task up. It's pretty quick to accomplish and nothing, too complicated here. So before I move forwards, Mario, I would like to talk about the failing Cypress tests. So initially, I thought that it was some versioning issue, which it could have been easily, but then I realized that before I make assumptions, are you also installing the Istio control plane before deploying all those patterns, or you're directly deploying the patterns?
Mhm. Good question. Well, I thought I was, um, but to be honest, I think that what gets installed is just like the Meshery Istio adapter.
Mm-hmm. Yeah. So
Yeah, I was in the. I might have been in the wrong assumption that running Meshery Istio, like as the CI/CD is doing, also like handled installation of
mhm.
Istio.
Yeah.
Uh,
So to install
I think
Istio.
that either it's not doing it or it's doing it for the wrong version. So
Yeah,
yeah.
so actually you'll have to install Istio, because when you install Istio, the Istio control plane actually goes ahead and registers those CRDs with the Kube API server. So although we have the schemas and we can ask Kube API server to install something like Envoy filter in your specific case, but the thing is Kubernetes won't recognize it because Istio control plane is not up. So if Istio is not installed, there is no point in things like Envoy filter and virtual service, because they are pointless because the control plane is not running. So I think you should go and install some different pattern. Maybe if you can install two patterns at once. First, you install the Istio normal Istio installation pattern, which you can find there in the service mesh patterns repo. And after that is installed, you can then go ahead and install the other things. Or there is a minimal book info Istio something by that name. That pattern actually installs the book info app, and before installing book info app, it makes sure the Istio control plane is running and all those things. So you can just deploy that pattern, and that would be good enough test according to me.
Okay. Yeah, I partially agree with that. Uh, I also think that it's a good opportunity for um like, can someone pop up the samples, the pattern samples? Thing is that, well, part of the issue that got solved, like the idea was to how can I explain it? Well, basically, just so we want to test that the samples we have in that repo, that they're working as we continue making changes, right?
Mhm.
So I don't know if it's negotiable. Like, is there a way we can kind of like update those samples, or I don't know. Like, idea is that the samples work, right? So the CI/CD, as per prior discussions, like, we'll eventually want to add more and more uh, different patterns that get updated. So maybe I might have missed some kind of README in there that talked about the prerequisites.
Yeah,
Um,
actually, most
is there
patterns.
any?
Yeah, actually there are prerequisites. I mean, recently I added a feature about importing patterns, and there I actually talked about that in our service mesh catalog, we'll have two things: that what you can configure in a pattern and what are the prerequisites. So for example, this Istio filter pattern, nowhere does it say that it has a prerequisite, but it's like, I mean, it's it's something like of a common knowledge that if you're installing something like Envoy filter Istio, you have your data plane or control plane set up, and that is why you're dropping these filters. And if you don't have that already set up, then it kind of doesn't make sense. So it's not explicit that the prerequisite for this pattern is that you have a installation of a for example, here also you can see the workload selector label is version v1 and app API. So basically it assumes that you have your deployments running with these particular labels. So of course almost all patterns have some prerequisites, and when we will upload them in the service mesh catalog, we'll make sure that we'll tell them what the prerequisite is. You have to install this particular thing, and that thing will make sense in that particular context only. So this thing that you are trying to install, it tries to install Envoy filter. But the thing is that as there is no Istio control plane, the Kubernetes does not understand it. Although we understand it, that's why there is no problem on the Meshery side. We have the schema. The Kubernetes doesn't understand it. The same goes with the book info pattern, because here also, as you can see, you have things like virtual service.istio and all. Although, if I'm not mistaken, you are using, you are deploying this book info pattern in the /API/application/deploy endpoint, right?
I'd say yes. Just right now, I need to take a look, but one is Istio parent deploy, and the other one is the book info. I just can't recall. I think that the Istio filter pattern is on the pattern route,
yeah,
and the book info pattern is on the application
so,
route.
So since it is
actually,
UI,
just a question. So, but the error message seems to point that like that's so there's a CRD that's not available, correct?
which error message? The Istio filter pattern one, right?
Okay,
Yeah.
but then again, what I'm seeing is that at least by the message itself, it looks like Istio is there, or not. Is this assumption incorrect?
Yeah, Istio won't be there actually. The message that you're getting, the error that you're getting is from Kubernetes itself. It's saying that I don't recognize this particular resources. Because since Istio isn't installed, it has not registered its own custom resources with the Kubernetes. So yes, that assumption is actually wrong. We cannot assume that Istio is already there. The work of when you install an adapter, it doesn't install service mesh for you. It's just there. You have to, yeah.
Okay, one question. So why does it say that it's not, so no matches for kind, Envoy filter in, and then it says version network.istio.io v1 alpha 3.
Yeah, exactly. So Kubernetes has this concept of GVK, so group version kind. So it goes into that particular, when you specify your kind and things like that. So it goes into, for example, in our, when this particular pattern is evaluated, this thing is when evaluated. So we actually, when we are when we try to deploy this thing, our adapter, what it does is, of course, we're at the end going to talk to Kubernetes. So it creates basically a Kubernetes manifest, and in that manifest you see things like kind and all. So there you have specified thing like networking.istio/ something. So that is your group and version. So what Kubernetes does is it goes into that group and version, and first it tries to find that is there this particular resource in this group version. So of course that group version itself doesn't exist. So that's why it's giving the error that in networking.istio, whatever that version is, whatever that group is, there is nothing of this kind in that group version. So that GVK is not available with Kubernetes itself. So that's why I actually tested it after deploying and before deploying, and I got the issue will resolve if you have your basically, because that error is from Kubernetes. We cannot do anything about it.
Okay, can I share something? So I think, I agree with your resolution. Like, I think you did like a really good, how can I say it? Like good investigation. Just a sec, I'm trying to share the screen. Okay. I just found something that since some time back related to this problem. Can you guys see my screen right now?
Yeah, we can see.
Okay, thank you. So the error looks very similar to this one. So there's a closed issue in Istio. Not sure if you guys got a chance to see it. So issue seems to be closed already since some time back, but it seems to be like some empty profile like a specific scenario, right? And the issue is like, I don't know, it's just too similar.
Yeah, actually, this error is a very common error. So it's like
So we would see the same error on different circumstances, even if
yeah, a
it's
lot
not
of
there.
yeah, a lot of
Oh, okay,
circumstances.
got it. So then it really doesn't give like, okay. So okay, I got it. So then what should we do so that this stops happening?
Yeah,
You say
so
that we have to choose another pattern.
yeah, either we we choose a
But
pattern
then
where
one
we
question, if we do that, we wouldn't be able to test integration with Istio, like in an end-to-end
actually
perspective.
yeah, okay. So what I can do, and because we have the pattern import feature right now, it is pretty easy to do. I can have a pattern where, for example, let me share my screen.
Sure, go ahead. I'll stop sharing. Thank you. Yeah, I just saw Lee nodding after me saying like the
Yeah.
Istio thing. Cool.
So for example, I can create a small, so this, instead of directly using this istio filter pattern, what we can do is that I can write a small another pattern where basically what I'll do is I'll first import this minimal book info app, or maybe basically I'll import this istio filter pattern where I'm first installing the Istio installation. So after the Istio installation is complete, I will add like here I have added book info. I'll create another pattern and basically upload it here
I
on
get.
under the samples, and then you can use that. And that pattern would be exhaustive of most of the things that we would want to test, so that you can just use that pattern. That would import
Okay.
filter and everything, and that pattern would make sure that everything is installed. So you don't
I
have to worry
get
about
you.
those things.
One question. So a pattern, I don't know if is it viable to make our sample patterns like independent in the way that they either install dependencies that they need, but I'm not sure if we run, let's say we have pattern 1 and pattern 2, and they both will install Istio. Would that cause an issue in like would Meshery fail out because oh, this is already there, or would it just say, oh, that's there, let's keep going?
Okay, so you're saying that a pattern that always works by figuring out what are its dependencies, right?
Yeah, I mean, how declarative is our current engine in the sense that
I
well,
think
yeah,
it's more upon,
idea. Yeah, go ahead. Sorry.
I think it's more upon the order of that pattern. So whoever writes a pattern, that person is aware of what variables this particular pattern can expose and what are the prerequisites. Any particular assumption to be made is pretty short-sighted. So tomorrow we can have a complicated pattern, and then it would get chaotic about to figure out what do we need to install first and the second. So it has to be explicitly, someone has to explicitly say this, that and that's what I propose, that when we'll upload these things in service mesh catalog, we'll actually tell you that this pattern is self-sufficient, or and this pattern is actually
Okay,
requires you to
so
install
we'll
this.
just document out what
Yeah,
dependencies are in each pattern.
yeah,
It's
yeah.
just that these patterns, like we're still building them out. So this is the reason, like this is happening now. But when we document this more, it'd be
Yeah, so
simpler for any user, right, to know.
yeah. So the idea is that patterns should be atomic units of things that do one thing and they do it good. So for example,
Sure.
this is a minimal book info .yaml pattern. So this pattern will install your Istio control plane and it will install your book info app, and this is what it does. It does not make any assumptions, but there are still patterns who make some assumptions, but they that one thing basically they do one. For example, this Istio filter pattern, its job is to basically apply these filters, apply the rate limit filter and this generic Istio filter onto your data plane. So its job is that, and it of course it assumes that you have your control plane already installed.
Okay.
One thing we
Yep.
can do is that basically in each pattern where we do these things, we can have an Istio installation again, but that would make everything complicated, and patterns would a lot of noise would start to accumulate on a pattern. So it would be even better. The better option would be to actually
Yeah.
document it somewhere, that
Yeah.
or maybe
Yeah,
we can
because
easily
I
we
agree
can
with
make
you.
it a,
Because go ahead. Sorry.
yeah, you go ahead.
Oh, sorry. Yeah, so you're right, because we want to make Meshery smart but how smart we want to make it that it'll,
Mhm.
like, some users will like that behavior, but others might
Mhm.
not. So we need to keep, like, try to be as unbiased as possible.
Yeah.
Um,
Yeah.
yeah,
So,
so we could talk about different scenarios, and depending on which scenarios we're talking about or use cases, some decisions might seem more rational than others,
yeah, so I'll
right?
give you one use case when that would fail. For example, let's say that we have a pattern file, and in that pattern file, we have a service which is very generic. Let's say that, eh, and for example, here your type is very, Envoy filter Istio. So you know that you need Istio. What if tomorrow you'll have a type of resource that is available both in traffic and in Linkerd? Which one would you install in this case? Because the same type is available in different service meshes. So we cannot make assumption that this type is associated with that service mesh and this type is associated. The way Meshery is designed, it does not make any assumptions, which makes it very
Uh-huh.
extensible.
Uh-huh. But when we say type Envoy filter Istio, so that does make an assumption that it's for Istio, right?
But yeah, but in this case,
In this
only in
case,
this
yeah.
case, yeah.
But generally
And,
speaking,
generally
we
speaking, we don't
wouldn't.
make assumptions. Yeah, we don't make
Okay.
assumptions. Like Envoy filter Istio, this is our core component. Internally, what we are doing is we just convert this thing into Envoy filter, the actual Envoy filter. We have just a very thin abstraction. We just take this. So basically here, as you can see, type is very explicit, but in a lot of cases it won't be. And in future, if when we build higher order components and all, we can really not be sure about what thing that. So there are traits which can be applied on multiple workloads, and basically the idea is that we don't make any assumptions. It's up to the user. So that's why we don't want to enforce any kind of you have to install this and install that. Basically, a better way would be that whenever someone writes a pattern, what they can do is they can comment out on their YAML that, hey, this need that assumption. Very basic thing to do. Or if we upload it, we can tell the users that up until this point, no one pointed an eye to this, because things were like very obvious to at least to us people who are using service meshes, that of course
course.
you're using an Envoy filter, so you need an Istio, so that kind of thing. But to new
Uh-huh.
users,
So
we can
experienced
really
people, like, really don't bump into these kind of problems. That's correct.
exactly.
Yeah. One question: Do we like the current message? Like, is it descriptive enough? Let's think about we're a user, like, we probably not that familiar.
Actually,
Would that be the most common case? Like,
the
maybe
message you're talking
50.
about is the one that that this version is not available, that one, right?
Yeah. Would the user know what to do next?
Actually, yes. The reason is because we are not. That's not our error. That's Kubernetes error, first of all. So if
Yeah,
user
totally.
so if user gets into that error, we are sure that okay, so there is some problem with the Kubernetes. For example, in this case, I just looked at the error, and there were only two possibilities. There was some versioning problem, or the resource is not available. So I think to have this kind of transparency where we just take that Kubernetes error and throw it onto the user is much better than to
Try to map it to our own domain and just.
yeah, exactly, because we cannot be exhaustively sure that what are all the errors in Kubernetes, right? So we want to have this kind of so that whenever user tells us that, hey, I cannot deploy this pattern, this is the error, it's coming, we can look at the error, and in that type of we have the meshkit error, so it actually says that okay, so while deploying this component, they had this error, and then as
Okay.
we can figure out that okay, so the Kubernetes threw it actually, so we can go from there. So I think it
Okay. Yeah, it makes sense. Yeah, it's just that when the user installs Meshery, there is a flag to choose a specific, like, adapter, right? So then, just to make sure, when Meshery receives that, okay, Istio, okay, that flag, it'll use that adapter. It'll grab it from wherever. Okay, it'll have it. But then this doesn't install any version of Istio at all.
Yeah.
On the cluster.
That's right.
It doesn't.
That's right. Yeah. No, it doesn't. It does not install Istio, because how do we can have like 10 adapters, and users can have all the 10 adapters running. So we are not going to install 10 service meshes onto your cluster.
Oh yeah, no, totally not. But then what's the preferred way of installing it of a Meshery user? Like, is there a way in from Meshery interface to to go in and from, let's say, the
Yeah.
Meshery UI to
Yeah,
install
actually,
it through there?
yeah, so in MeshOps V1, you would see that that configuration page is that page. You'll go to that page, and it has actually, you can configure, basically there's a list of all of these service meshes there. So if you have your Istio adapter running, it will connect to that Istio adapter, and then wait a minute, I'll deploy Meshery.
Yeah, could you show like a flow? Let's say
Yeah.
a user just starts, they just
Mhm.
install UI, Meshery server, everything, and then they just want to use Meshery, you know? They're not
Yeah.
familiar with Istio, but they need it. Maybe they need
Yeah,
it,
of
but
course.
they just, you know, they're just playing around. So
Yeah.
maybe we can introduce like a bigger or wider integration test or end-to-end by exercising that flow and then making sure at least that if Meshery, if there's some flow that installs Meshery, like Istio, that Meshery makes Istio get installed, then at least we can make sure that it's installing it correctly, because after that, running that specific pattern that depends on Istio, at least that's my my opinion, you know, like, of course we're not like doing extensive things, you know, but we're basing that the user has a certain minimum amount of experience or knowledge of what needs to be there, you know. If we add documentation around that, that's good, of course, but at least when we're talking about a specific pattern file. When I left a while back, it was because I read Lee saying that the word pattern was being tossed around in our conversation. It was just so funny for me because, you know, he's absolutely right. You know, we're still like kind of like, you know, defining that. Go ahead, sorry.
Yeah, so
So-
here in your life cycle, actually, not configuration, you'll see, for example, if I click on Istio, actually my cluster hasn't, basically I didn't start my cluster. So here actually you'll see things like, yeah, in your, wait a second.
So hey, I'll chime in to say that we do have integration tests that that will build the Meshery adapter for Istio, stand up a Kubernetes environment, deploy Meshery server along with that freshly built Istio adapter or any of these adapters. And then it will invoke just the basic workflow of provisioning of Istio with just its control plane components.
Mhm.
And we almost universally have that same set of integration tests embedded into each adapter repository today. We don't go, but that's actually part of today's discussion, is to take those to extend those workflows. And so someone like Raj and Pranav and Hirsch, and well, like all of us on the call, but like some of these other guys, I'm hopeful that they'll be able to pounce on the framework that's there and start to add on additional use cases like, okay, well, so if the workflow and this framework is present for doing a Meshery deployment into a Kubernetes environment, and then doing the first step of like provisioning the service mesh, and it's basically empty. Okay, good. That's where we are. Now, if I'm Pranav and I'm looking at it, and maybe it's the Istio adapter, so I'm saying, is there a handy sample application here? Oh yeah, it's the book info sample app. And we have operations to provision that. What are the next couple of jobs, or whether it's a job, the next couple of steps in that workflow that can be added to just invoke Meshery's next operation of deploying the sample app onto the mesh? Good. Like that would be successful. That would be a whole nother series of tests that are rather just having that single step, that single next test would be would be incrementally helpful and would verify that it wasn't just that we stood up Istio and actually Istio doesn't actually work. It would be, no, it works because we deployed a sample app on it. So it works. And that's a big fat check mark. The next step being something like, oh, well, we have a handy service mesh performance GitHub action that can then be incorporated as a next step where, great, so we've got Kubernetes and Meshery, we've got an instance of the service mesh stood up. Now we've got a sample app deployed. Now, if we take this service mesh performance action that already has some of the hard stuff dealt with, and we say, well, we'd like for you to generate load, use Meshery to generate load against one of the endpoint, like the sample app, and then have it evaluate. It doesn't really matter what the performance is. The point was just, not only did we deploy the mesh, now we deployed an app on it, but we also sent a fair bit of requests towards it and it's responding back. So clearly everything is working. Okay, great, excellent, perfect. Those are two big fat check marks on the integration test, like the list of things that we need to automate. It'll be really helpful. Beyond that, yeah, you can get really expressive in any of the patterns to say, well, we want you to generate the test or generate all that load. It doesn't have to be a lot, but just generate a little bit of load. Before we do, so in between deploying the sample app, let's actually apply a little different some specific configuration to the mesh. Maybe let's intentionally drop 50% of the packets, or like let's intentionally divert some of them over there, or like let's deny them unless they have a certain token of a certain format.
Some policy.
Yeah, and that would be it's not like we're trying to, like the point of doing that isn't to rerun all of Istio's tests for Istio just to verify that Istio is doing what it's supposed to do. The point would be more like, no. Meshery's capable of not just like
interfacing with it.
Yeah, at all levels of specificity. And so we're not going to hit them all. It would be pointless for us to go hit them all. And it doesn't really,
totally.
But if we kind of touch the end of a few of them, it's like, okay, there's super high confidence that if you redirected 25% or 75%, or like all those tests, Istio can deal with, but this, could we just make it to the end and did things flow? Then we're pretty safe to assume everything was correct. There's just a couple of key points to check, and that's actually where we are. This output here is showing some of those individual adapter tests and whether or not they're being successful up to the point just before we would provision a sample app. So that's actually a call to arms on this call, is like a call for all of us to go. It's one of those things where when one of us writes a small little workflow that deploys a sample app, that we basically want to take that and go add it to the other adapters. Maybe we use some sample apps on this one or that one,
Yeah, so to answer Mario's original question, if you have a running adapter and a user wants to install service mesh, how can you do it? It's pretty out of the box. So here you can, on my dashboard, you can see that I'm connected to my Minikube cluster, and also I'm successfully able to ping my adapter. If I click on Istio now, this used to be the only way you could install Istio. This is what we call MeshOps v1 as compared to MeshOps v2, which is using patterns basically. So here you specify your namespace, although because Istio makes it compulsory to install your service mesh in Istio system, so we override this anyways. So you specify your namespace and you click on add, and basically this installs your service mesh. So it's like one click thing to install your service.
So it just invokes like most default Meshery, Istio install script from GitHub, right?
Not from GitHub actually. The way we install Istio, basically, yeah, there is a
Helm
default installation. yeah, through Helm. It installs
Okay.
egress gateway, ingress gateway, and basically it's not the default installation. It's I think it's called demo installation. They have different profiles, so it's the demo profile. So because this used to be not so basically you cannot customize the way you want to install it. Basically, you know, you are there's this kind of basically it gives you an ability to just click on this plus button and install it. But what if you want to choose a different profile? And also see, now I got the notification that Istio service mesh installed successfully. Although this thing is pretty, as you could see that I clicked on that button, then I had a conversation, and then after a point we had this thing. So one of our next things in our .7 roadmap is to have a notification center. The way basically or at what stage we are at while evaluating this pattern, we need to continuously pump that data onto the UI so that user is in touch of what's happening. So yeah, to my original point that here, as you can see, yeah,
that's
it's like
just click in there, install, and just wait for that to return like a good response, and or see that message, and it's installed.
Yeah.
And now running a pattern file that depends on Istio, it would work.
It will
cool.
Work. Yeah.
Okay. One question. Okay. First, I want to say that Lee is totally like nailed right on spot with the confusion that the adapter chips. It makes the user or any dumb user like me think that Istio is installed when it's just interfacing with an adapter, and that doesn't mean that it's actually installed. And so, for example, do you have console installed right now? No, right?
The adapter or the service mesh?
Okay. You mean okay.
So these chips
both.
are just to when you click on these chips are basically the request goes to Meshery server. Meshery server creates a gRPC call to the adapter, and it asks if the adapter is up. So these chips are just as you can see local. I mean, you can see local host 10002. So it's like it's a running server. So if we were pinging a control plane, I mean, you would expect it to be not, something like this. So these chips are just adapters. That your adapter is ready and it's available to perform operations.
Yeah, I ask you this because I noticed we have a bug in one of our other tests. So there's an E2E test in the Cyprus folder. So there's this setting spec. It checks for service mesh API. What's the page? The settings page. So if you go there, and if you click on, let's say you select the second one. Sorry, still reading this out. So basically, it's about chip adapter location. Okay, is there a place for the service meshes? Okay, yeah, service meshes, please. Okay, tap service. Okay, we're here. Can you select the one that is for this console?
I could, but basically I won't be able to connect because I'm not running the adapter right now.
Okay, but we are hard. It's because the test is hard coding that it's the import 1002. Is that correct? Is that for console?
Yep.
So it is. But the problem in the test is that it's not really asserting the response. It's just waiting for the response to return. So you would get a 500 or something, right? What would you get in here?
If I'm not running the adapter and if I try to connect.
Let's say you have the adapter.
Okay.
But
let me start the adapter then. My adapter
sure.
is starting. It's taking some time because I'm not being gentle with my
but do you know the answer? Like, let's say the adapter is running. Would this return 200 or some other error?
If the adapter is running, then you'll see a second chip. It's 200.
Okay, but so then as I'm trying to say, so that test is okay. It's just missing the it's not looking at the response, just waiting for the post API system adapter manage.
So you're in your test, you're clicking on these chips basically.
Well, it's clicking on the submit. Which one is that?
Actually,
so it's selecting one of them.
The adapters have a default port. So if you already have, for example, in my case, I'm already running my adapter on this local host 10002. So that's why it auto detects it. But if you're running it somewhere else, let's say some different domain and different the address is different, then you can manually enter that
Yeah,
address.
override
When
that.
you you'll override it. When you click connect, it'll try to connect to that particular whatever address you specified.
Yeah, no, yeah, I think that the CI/CD installs it in that same place. You know, this other test was written way back, so I'm just trying to understand the difference between the adapter and the actual mesh. But okay, I think this is good enough. I'll just write an issue to add that instruction. So we're waiting for that post, but you know, the test is not adding value. It's the ping and submit console, but it's not inspecting the response. So it could even be returning a 500 and we wouldn't even notice. So, but anyways, yeah. Or if would you guys want me to show up that, or totally fine omitting that?
Wait, to have it, you were saying to have a test that confirms.
We have a test. We have a test. It's just missing one instruction, and I think, you know, I think it's relevant because we have some tests, but I think that the communities, or at least the contributors, you know, it's like a black box. Or does anyone disagree with that?
Yeah, no, well, wait. So Raj, I was just kidding about not a word about not being able to access Figma because you had to go through that pain. So, by the way, Pranav, is it you don't have a different, is your Hotmail address Google account backed? Like, can you edit Google Docs with?
No, actually, for Google Docs, I use a Gmail account only. So shall I send it to you?
Yeah,
I
please.
can send it. Okay.
You're great. I just share your embarrassment with that Hotmail account. Just so I'm totally messing with you. Mario was saying, Mario, I heard black box, and
Yeah, so I think that with these tests, so the ones we're looking at, so these are based on each adapter, right?
Right.
So okay, so I think that's it looks like that's very broad by itself. But when we talk about Meshery UI, Meshery server, and the end-to-end tests we have that are with Cypress, I think that's where maybe it's the wrong impression, but I think that it'd be good to share like a bit more of how those are scripted and what they're checking, and just clarify what they're not supposed to check, so that we're all on the same page, at least for now. What's the actual scope? Like, what are the objectives of those tests? I don't know.
Yeah, absolutely. Yes, that's it. Yeah, that's actually kind of on today's agenda. If we were to bring up the
let's go with the agenda.
Yeah, no, yeah, but actually we'll like roll right into what you just said, which is, I mean, there may be multiple aspects, multiple facets to what you just said. One is, if anyone is able to take the time to integrate the output of the Cypress tests, if we're able to programmatically retrieve those and add them to the test results in the docs, that would be beautiful. Because then like the question that a lot of people just want to, in general, you'd want to say, hey, so I'm working with this service mesh. So I want to take a look at the tests that are done with the representative adapter. Okay, let me take a look at those tests. And so whether those were run in this workflow or that workflow, or using Cypress or that tool, like from a user's perspective, like while we want all that detail, and we want to know that when that failed test was to run by Cypress and as it was run based on this, and we can have all that linkage and that detail. What someone else
visibility, right?
Yeah. What someone else is looking for is sort of the high level summary that says, well, I'm running Kubernetes 1.22. I'm using console. And I'm also running it in Azure. And so how is Meshery doing? Is Meshery compatible with that? That's in part why the integration tests page is actually named compatibility matrix. Like, we're not quite there yet, but the goal is to roll that up into a summary that says, here's Meshery's status of compatibility across the various versions of the meshes and the various tests that we run. Like, does it provision the control plane? Does it provision sample apps, and et cetera? The other aspect to what you are saying, I think, can in part be facilitated if Ashish, if you go into that spreadsheet that's linked in the second topic, this is Meshery's test plan. It is has a lot of tests, and it also is missing tons of tests. But and that's fine. Of the tests that are defined, well, there's you can test Meshery CTL, you can test Meshery UI, you can test just the adapters and their gRPC interfaces. Like there's various vectors from which you can invoke a test and have things run. Hirsch has been through some of the work that he's been doing on performance testing. He's invoking that's sort of like top level. He's sort of invoking the full kit and caboodle because he's running performance tests against endpoints that have been deployed onto a service mesh, deployed by Meshery and all that. So in this spreadsheet, there's individual tests that are specified. If we're able to identify which of these are covered by Cyprus or by a workflow run that's separate from, the goal here is we have now automation frameworks in place that have been running for a bit and are doing fairly well. We're in a position now where we can go just add additional tests. Like the framework and the system is all there. We just need to add some additional tests. And this is a great way of, to what you had said, Mario, is to like identify what functions are in Meshery and which ones are covered by a test and which ones aren't. Now, if we can link including the link to the Cypress definition, like the test case definition, great. Like, that's excellent as well, because ultimately, eventually, like it's kind of an interesting thing. When we first start, you start with a blank spreadsheet, then you add some test cases for Meshery CTL, then you add some for Meshery server, then for the other components. And then you get better at defining what they're supposed to be like. Then you get better at saying, well, that should work on this OS, that cloud, this Kubernetes version, and all that. And then you go through and you try to automate some of that. And so we have automation frameworks in place for most of the components, the adapters, and then finally you get into like, and then we're coming back here and we're kind of documenting the fact we've got all these covered. Eventually, it would be great if we could hit delete on this spreadsheet. And what we're ultimately looking at is basically the same content, but in the docs itself, that are just like the systems and the frameworks are just auto documenting what's covered, what the status was. Yeah. And we're kind of there, like, okay, we already have some auto documenting for the tests that are being run against the adapters. And so that provides like the hard part is oftentimes getting the framework in place. And then from there, you can kind of run wild and automate the rest of the tests, So great, Hirsch. Yeah, we should, I didn't see Hirsch's message. Mario, are you good with what I just said? Is that
yeah, I think it makes sense. I just there were we discussed about what approach is best, and I did propose making those tests so they're commented out, but so I can create a task and then work on that. And the idea is to my suggestion is that we can cover yeah, it's kind of confusing. So we can cover a bit of the lifecycle management if we want to do that, right? I can just make the tests, whichever test that needed that do the deployment. Just whenever they need Istio, they could have just make sure to go into that page and click that button, install it on the cluster, which it seems the simplest way. And also we could also kind of test a bit of integration of, okay, when a service mesh gets installed in that way. Not sure if that's already tested anywhere. It might be redundant to do that. No, okay, good. And then awesome.
Yeah, it's kind of both. It's sort of in some respects it's redundant of what the tests that are running for the adapters, but on the other hand, it's
now we're integrating that. Yeah, the server, it uses that. Okay, yeah, good. So then that's totally, it's okay that they overlap.
Yeah.
And then, once that's done, of course, we could also do that through an endpoint just so that it's fast. Okay, just keep it things fast. And then since those tests are like based on the same template, basically, I think I know what to do. So that solves the problem without adding like extra, like the other ideas were good, like adding like running other pattern, etc. But I don't know, at least that issue that was attempted to be resolved is like to actually test those patterns, and I think this approach would solve like issues. And I think that like really appreciate like the clarification from Ashish, like that's great. So yeah, I'll just follow with that, create some issue for that, and or I don't know, maybe reopen the other issue. I don't know, but I think it's all for now. Thank you a lot.
Yeah.
Thanks, guys.
I'll try to follow up as well to make sure that some of the folks.
And I did ask a question like, okay, this specific scenario, do we care right now, or would we want to capture like how a user would just see that error? Like, again, I like to reiterate that it wasn't that easy to identify. I didn't solve that for myself, and so
there's a few,
so how can we capture that for a future enhancement of that? Like, of course, we'll not do extensive things, but I do know that Meshery has a capability of doing some dry run and something. It's just that probably we're not using that for that specific deploy workflow. Like, what do you think, Lee?
I'm gonna absolutely.
Like, can we just check at least that, okay, Meshery is not installed, let's just output that. Like, it's not, I don't think that's hard to check, is it?
Nope. Nope. And Pranav's work on the notification center is going to help with some of this to really explain to people that, like, hey, actually the pattern failed, not because the pattern is bad, but because there's a missing dependency potentially. And then other work eventually will make it much more obvious up front that, like, hey, you shouldn't even attempt to deploy this thing because there's a missing dependency, and here's what that dependency is. And like,
Okay, so then do we consider that enhancement in the scope of the notification center itself, or does the deploy, let's say the deploy application, deploy pattern, like, is that something else? Like, would we use that solution in there as well? Like, I'm just curious.
Yeah. The nice thing is that most of them will benefit from the same logic, the same underlying logic saying.
I got it. Okay, so then that's why we're just focusing on the like the usual path. Okay, like just let's just add the step to get that installed and you just make sure it works. Like, okay, I think it totally makes sense. Thank you.
Yeah.
That's all.
Hirsch, you've got.
Hi. So I'll keep it short, mainly because I probably do not have the energy today to keep up. Right. So this is what this is a run that I did for yesterday's meeting. Unfortunately, we did not have time to cover this. So I added and I sent you that I was getting this particular issue. However, this still ran that particular test, and that did show me that the test ran successfully. I'm not too sure how exactly this works. Or is this an error which panics and sort of exits that exits Meshery, or like shuts that process down or something? I'm not totally aware of it, but given it is running a test and it's completing successfully, I'm assuming it's not doing that. Actually, I had also taken up a Helm issue. I think you know that. So I thought that before I context switch there, I decided to just give the scheduled case and the cases which run which run sort of in a scheduled way. Or let's say what this manual does, although I run it manually, but what this does is that it runs 4 tests consecutively, one after each other. So that somewhat gives me a proxy to how scheduled tests in general will happen. Right, any certain configuration can just pop up anywhere, anytime, and then just we need to make sure that we can handle that. So I was working on that, and I was working on that yesterday, and now I'm at this stage where all these 4 particular tests are succeeding, right? So either one, if you like, you just see this
Sorry to
one,
interrupt. One question.
Sure.
Why are they called manual? Is it because they're triggered manually?
Yes. They're
Okay,
triggered
got it.
manually. They're
Thank you.
triggered manually, and then there's this scheduled part which
Okay.
runs on a schedule. So I'll
Cool.
do that. Currently, this is configured just for the master branch, and I'm working on a separate branch. Right? I'll probably configure that as well later. But given these manual, right? So manual, you can see that I'm currently using one worker. Right, this one, there's a machine I created in Tokyo in Equinix, because Tokyo is closer to India and Dallas is away from India, so I'm not creating any more machines in Dallas because that's laggy. So now because of that, it runs one by one. So when this runner gets free of that one particular run, it picks up the second workflow, then it picks up the third workflow, then it picks up the fourth workflow. However, if we like, and that's what I think, because I noticed this in the other cases as well, that if we supply 2 machines to it, then it will probably parallelize them and run them together, right? So, and it will share the load across the 2 machines, and so on and so forth. For if we increase the number of machines, obviously up till 4, because 5 doesn't make sense for 4 tests, right? So I've been able to do that. So there were a couple of caveats that I had to solve, that, and those I have been able to do. So I think this would certainly assist with what Jin is doing himself. So mainly he focuses on the workflow part, and then the scheduled part, maybe at least the hardware side and the whatever OS permissions we're getting into, and whatever small caveats they're about cleaning up that particular instance after we're running. I'm trying to handle those right now. And right now, I do think that this 4 checks is a good sign. So what my idea would be to sort of set up scheduled tests on that particular branch that I'm working on. And I hope to wake up to mails of successful runs tomorrow, right? So that's what the idea is. And then I'll probably context switch to that Helm issue. Right. So this is it from my side. Nothing more.
Quick confirmation: the clusters, that it's still a single node cluster that you've
Yes.
worked with.
Actually, yes. I had a question. On that. So when we're speaking about, let's say, multi-node clusters, and we're speaking about, let's say, running these particular tests, right? So ultimately, we aim to sort of run a few tests on that machine, or are we thinking, let's say, our entire service mesh sort of consists of containers on multiple hardware, or that sort of a thing?
Yeah, it would be that the service mesh itself is operating cluster wide, and and so across nodes, so that yeah, if there was a 3-node cluster, we install a mesh, and then install, and the namespace spans nodes in the cluster. The tests themselves, or I think the vast majority of the test itself, probably the workflow probably doesn't change much. It's mostly just the initial part of ensuring that 3 individual nodes, that the Kubernetes cluster is initialized with multiple nodes. And actually the rest of the test, it'll still just be one Kubernetes context, one kube config, left to the default behavior of Kubernetes. When we deploy a sample app, it'll get spread out across the cluster, across the nodes. And yeah, no, it's more, like it's more just the Equinix Metal, provisioning of an OS, and the dynamically feeding. I don't know if it would be dynamic, or ideally it would be dynamic. We dynamically feed the workflow, the automation, not necessarily the GitHub workflow, because I know you've got automation within Equinix Metal outside of that. But to the extent that you grab 3 nodes, Kubernetes, the OS gets deployed, Kubernetes gets initialized within a multi-node single cluster, and then the rest of the test is the same from there.
Right, got it. So I think I will do that with Zhen, but I think this probably is a good start to at least handle sequential tests or tests running up one after each other, and kind of for you could say the minimum possible cleanup that we need to do in order to be able to successfully run tests at regular intervals. So I think we are one step closer to that. Like I think we have that minimum thing. Now maybe we do some more optimizations as well on this.
That's awesome. Yeah, are these manually invoked tests the environment that they're running in? I think you just answered this question of mine recently, so I apologize, but are they being torn down, or to what degree are they being torn down today in between tests?
Not a lot. Not a lot. So it's ultimately the hardware and the users, etc. Those things remain same. I do uninstall the Minikube cluster, and I do sort of tear down the service mesh part, but the service mesh packages mainly because I was getting one small issue there. So I just tried doing that. But other than that, everything remains constant in that environment.
Cool. Good. Actually, in some respects, that's an even better answer because then one mesh can't say, oh, well, you can't compare these because when you provisioned, you were using that specific hardware over there, and now you're using a different one from this tech. So that, yeah, that's great.
So then it's same hardware, and it just so the Minikube cluster is torn down and raised like from scratch between one test and another. Correct.
See, right now, what I am doing, I am not tearing down the entire hardware. I'm not sort of forcing any reprovisioning or anything of that sort. But I think eventually, the way Jin explained in his particular flow, the way he's probably going to do that, he's probably going to use Terraform to provision servers on demand when something is run. So I think that in a way that flow would mean that we are provisioning servers at the start of the flow, means we're tearing down that entire cluster at the end of the flow. So I think in the final flow, this would be the idea. However, right now, it's just one after the other, and I'm ensuring that all these tests are done. Yeah,
I think it makes sense because, of course, eventually we'll want to do that cleanup because, there's a concept of, by continuously using that same, let's say, probation things, we could eventually see some degradation, but mainly because of like whatever data that's still there. Probably not in this case, but usually, that's like the importance of cleaning up. But yeah, I think this is a good progress. Maybe I'm just too like unfamiliar with all these performance part. So Fortio and Work2. So are those two? What are they like? Looks like configuration, but anything more specific than that?
Right. I think, right. So Istio, these are service meshes. Fortio, I think it's that. I'm not too sure. I'll just.
I think it's like the performance tool used, right? Or not?
Yes, I think.
It's okay.
Yeah, it's the performance tool. Yeah, it's the performance tool. Yeah, it's actually both of these are the performance tools. Yeah.
All right, looks good. And what endpoint is being triggered, or what's the actual test consist of?
Right. What the actual test consists of is actually a perf run. Like you just do a Meshery CTL perf. You could see it in the code. I don't think it should be different from the master per se, but there are some changes. So ultimately, it's perf apply, and then you give configurations. Then you give give all these. So mesh name, load generator.
So it's basically is it the health endpoint of each service mesh?
Load. I don't know. I don't know the specifics of Meshery CTL per supply.
Oh, but that's defined in a specific configuration file then, correct?
Right. So the configuration file. Yeah. So here what we're doing is we're using something called as load test. This is what we supply. This is what we're supplying. Right. So load generator is for sure. Right. And then we are basically running this onto right. So there's another one. There's something called soak test as well. So these are the two things that are available to me in order to test right now. So I'm using both.
Excellent. Looks good. Thank you. I'll read more about it, all of this. Very interesting things.
Cool. I mean,
Yeah. Hirsch, that's it. That's exciting. Yeah, I can. I don't think that those tests are lying to you. That they probably are. They probably are completing. We have to look a little bit more. We need to empower you to be able to verify that as well, to see the specific output of those tests as they get captured in Meshery Cloud. And so that's good. So by the way, it's been too long since we've had a service mesh performance meeting with Shin and you and the others to help take those next steps to kind of help get us all on the same page. So soon, maybe it's next Thursday. I'm not, I have to look, but it's really good. There's Isovalent was just reaching out. They're wanting to participate. Yeah, I mean, I can't wait for us to start publishing.
There were 2 more items in the agenda, right? But I think we're out of time.
Yeah,
so
but yeah, we're on top of time. So I think we can conclude now. We're 4 minutes after. So we'll, if there was one agenda item for Pranav, we can maybe continue that in the dev call or in some other call. So it was good to seeing all of you. See all of you in the next call. Bye-bye.
Thanks all.
Thanks, Ashish.